Hello everyone, class 12th topic is phenol and its preparation method, Dow's process. In previous videos, we have covered the first organic compound of this chapter, alcohol, in which we have done different type of alcohols, their preparation methods, chemical properties, and their distinction methods. The last distinction method we have done iodoform test. Now it's a time to understand next organic compound in a same chapter, which is phenol. Many preparation methods are there. In this, the very first preparation method and very important because it's a named reaction, Dow's process. This we will discuss. Mechanism we will not discuss in this chapter, in this video, because mechanism of the Dow's process is not in the syllabus of 12th class. In next video, I will tell you mechanism of it, which is important for JEE Advanced, NEET and BSc. Now let's first understand what is the chemical formula of phenol. Benzene ring, as we all know, 6 carbons are there, cyclic compound it is, hydrogens are there, and at the place of one hydrogen, if we have OH group, oxygen is connected with this carbon. It's a chemical formula of phenol, in which oxygen is carrying sp3 hybridization and the carbon to which it is connected is sp2 hybridized. Even all carbons are sp2 hybridized here. This oxygen is carrying 2 lone pairs and second bond it is making sigma bond with hydrogen. This benzene ring we can represent in this form also, like this. This circle, we know it represents delocalization of pi electron, resonance, the movement of pi electrons. The pi electrons, these pi electrons are continuously revolving over entire benzene ring. That movement is represented by this circle. So sometimes this is as a benzene ring written here, sometimes this. So don't get confused. Same formulas there. Or one more way is there. Position can be changed. Pi electrons are that side. In this fashion also it can be written. It is benzene ring, it is benzene ring, it is also benzene ring. So all three formulas can be used to represent phenol. Now let's understand what is Dow's process. Phenol is a colorless crystalline solid. Colorless crystalline solid. It is available to us in a solid form. Crystals are there, colorless crystals are there. We call them phenol. In Dow's process, chlorobenzene, this chlorobenzene, a colorless liquid, going to react with sodium hydroxide aqua. To balance it, let me write how many particles of NaOH will be required here. For one particle of chlorobenzene, 2 particles. If I talk about conditions, very high temperature is required, 623 Kelvin, and very high pressure is required, 300 to 350 atm. In this condition, firstly, it is going to create this. This is sodium phenoxide. Side products will be NaCl and water. NaCl and sodium phenoxide both are soluble in water. This on treatment with dilute HCl will give you finally phenol in liquid form. This process is known as acidification. Sodium phenoxide particles will be acidified with the help of dilute HCl, and finally we will get phenol, and the side product will be NaCl. Now, because mechanism is not in our syllabus, so definitely we require a trick to understand it. So one very easy trick we can tell you. First of all, let me tell you about this condition, why we required such hard conditions, 623 Kelvin, so much high temperature we required here, because you can check in this reaction, you have to break bond between carbon and chlorine, this bond. And this bond breakage is not so easy because it's a haloarine, and haloarine are very less reactive toward nucleophilic substitution reaction. Already we have discussed it under the chapter of haloalkane and haloarine. Reason was it is showing resonance, due to which here we have partial double bond character. Means between carbon and chlorine partially double bond is there, and if double bond is generated means the bond becomes strong. So to break this bond, high temperature is required. And why we are maintaining this high pressure? Because at this temperature, this chlorobenzene and NaOH, which are in liquid state, will become vapor. For reaction, we need to keep them in a liquid form. That's why we are maintaining very high atmospheric pressure. So the reagents will be in a liquid form and continuous reaction will be there. That's why high pressure is applied there with high temperature. Okay, now let's understand this reaction in a simple fashion. How we can understand it? It's not mechanism, but a way to learn it. In chlorobenzene, between carbon and chlorine, chlorine is more electronegative, it is carrying partial negative charge, and this carbon is carrying partial positive charge. NaOH, as you know, will break in two parts, Na positive and OH negative. So that's it. You can check when chlorine and carbon bond will break, these two electrons will completely transfer towards Cl, and from here you will bring out Cl as a -1 particle because it is getting extra electron of the carbon, due to which this carbon you can say will turns to a positive particle. It's not a mechanism, it's a trick that I am telling you. OH negative will attack on a positive particle and Na positive will attack on Cl. So side by side what will generate? NaCl, and here this will generate phenol particle. But wait, phenol is acidic in nature. Acidic means it will deliver its H positive. Here we have basic condition NaOH. So H positive, OH negative, they will again combine to create H2O, and obviously between H and O bond will break, so electrons will completely transfer toward oxygen, due to which O will become -1, and from here Na positive will come, which will combine with O negative. So finally we will have sodium phenoxide. Again, let me remind, it's not a mechanism, it's a way to learn that reaction. Sodium phenoxide. Now finally sodium phenoxide is going to react with an HCl. HCl will break in two parts, H positive, Cl negative, because acids are those which deliver H positive. Obviously between H and Cl bond will break, both electrons of a sigma bond will transfer towards Cl, Cl will become negative, H positive. So that's it. There a positive particle will attack on a negative particle, NaCl will release out, and H positive will attack on a O negative, and finally we will get a phenol OH like this. So you can count how many NaOH particles are used. 1, and this is second, 2 NaOH particles are used in a initial stage of the reaction, and what is released out? NaCl and H2O was released out, which was in a balanced chemical equation, and then again sodium phenoxide was generated. Sodium phenoxide further reacted with HCl, you can check, one more NaCl will generate, and finally phenol will generate as a main product. So this is the way to learn that reaction. In this fashion you can understand that reaction, because mechanism is not in there in 12th class syllabus. That's it. Now in next video, we will understand its mechanism. Very, very important for NEET, JEE and BSc. Thank you very much for watching the video.